Have you ever felt like your computer is just, working way too hard for a really simple task?
Oh, definitely. Like it running a marathon just to open a file sometimes.
Exactly. Well, it turns out advanced AI can kind of have the same problem.
Right.
And that's what we're diving into today. Google's pretty interesting new approach with AI reasoning control in their Gemini 2.5 Flash model.
Yeah, it's a fascinating development.
So our mission here is to really get into what this new feature actually is, why it's potentially a big deal for AI efficiency and, cost effectiveness.
And what it might signal about where AI development is headed next.
Precisely. We're basing this on a recent article from TechForge's AI News. It came out April 23rd, 2025.
Okay.
And the main problem they're tackling, it's this idea that these super smart AI models can sometimes, overthink things.
Overthink simple requests.
Yeah, even straightforward queries. And that wastes a ton of computational power.
Which means higher costs, both money-wise and environmentally, too, I imagine.
You got it. Tulsi Doshi from Gemini had a great way of putting it, like using industrial machinery to crack a walnut.
Ha! That's a perfect analogy. That really paints a picture. Using massive power for something tiny.
Right. So Google's answer to this walnut problem is what they're calling a thinking budget.
A thinking budget. Okay, tell me more about that. It sounds practical.
It does. They released it back on April 17th for Gemini 2.5 Flash. And it basically lets developers put a cap on the processing steps the AI uses.
So you can tell the AI, okay, for this task, you only get this much thinking power.
Pretty much, yeah.
No.
Limiting the computational steps for problem solving.
Okay, but why is this needed now? Is it because AI is getting better at reasoning?
That seems to be the core of it. We've seen this shift, haven't we? From AI just matching patterns to actually trying to reason things out, solve problems logically.
Right, which is a huge step forward, obviously, for complex tasks.
Definitely. But the TechForge article points out this kind of unintended side effect. These powerful reasoning models sometimes use that same intense logic on really simple prompts.
So they're defaulting to the heavy machinery even when the walnut doesn't need it.
Exactly. Tulsi Doshi said it directly. For simple prompts, the model does think more than it needs to.
And thinking more means using more resources, which means higher costs.
Big time. Google's own tech docs apparently say that running in full reasoning mode can be, get this, about 6 times more expensive than their standard processing.
Whoa, 6 times. Okay, that's not trivial at all. That makes the business case for this thinking budget crystal clear.
Absolutely. Suddenly, controlling that reasoning isn't just a nice-to-have, it's crucial for managing costs.
And it's not just Google feeling this pinch, is it?
Apparently not. Nathan Habib from Hugging Face called this whole over-reasoning issue endemic. Like, it's happening across the board.
Endemic, wow.
Yeah, he had another great analogy in MIT Technology Review. He said companies are reaching for reasoning models like hammers, even where there's no nail in sight.
So everyone's grabbing the most powerful tool just because it's there, not because it's the right tool for the job.
Seems like it. He even gave an example, a top reasoning model getting totally stuck trying to solve an organic chemistry problem.
Stuck how?
It just kept repeating, wait, but, over and over again, like it was caught in a loop, just burning cycles without getting anywhere.
Yikes. Just spinning its wheels computationally. That sounds incredibly wasteful.
Right. And Case Oljevska from DeepMind apparently confirmed that, yeah, Google systems can hit similar loops too.
So it's a real problem then, this computational looping and overthinking.
Definitely seems like it. Which brings us back to Google's control mechanism. How fine-grained is this thinking budget?
It sounds quite flexible, actually. They've set up a scale, basically. It goes from 0, which means minimal reasoning.
Okay, like for really simple stuff.
Exactly. All the way up to 24,576 tokens.
Tokens. Now, those aren't like words, right? They're more like internal processing units.
Precisely. Think of them as units of computational effort the model can spend on its internal thought process. More tokens mean deeper. More complex reasoning is allowed.
24,000. That sounds like a lot of potential thinking. So developers can slide that scale depending on the task.
Yeah, that's the idea. Tailor the reasoning power to the job at hand.
But how do you figure out the right amount? Like, would asking what's the capital of France needs, say, 10 tokens, but debugging some complex code might need, I don't know, 20,000?
That's the tricky part, isn't it? Jack Ray from DeepMind basically said figuring out the perfect task right now for thinking is still something the field is working out.
So there's going to be some trial and error for developers using this.
For sure. A period of experimentation, learning how much budget different kinds of tasks really need to perform well without overspending.
This whole move, focusing on control and efficiency, it feels like maybe a bit of a shift in how AI is developed.
That's a really sharp point. For ages, it felt like the main goal was just scale, scale, scale. Bigger models, more data.
Right. But Nathan Habib, the guy from Hugging Face, he actually said scaling laws are being replaced.
Did he?
Yeah.
Interesting. So the old idea that just making things bigger automatically makes them better? That's maybe hitting a wall.
Or at least being supplemented. The article suggests maybe the focus is shifting towards more intelligent operation, not just brute force scale. Efficiency is becoming key.
And that efficiency angle has huge environmental implications too, right? We hear so much about the energy cost of training these huge models.
Exactly. But the article points out something crucial. The inference part, actually getting answers from the AI, is now potentially contributing more to the carbon footprint than training was.
Wow, really? So everyday use is becoming the bigger energy hog.
Seems that way. So a control like this, if it makes inference more efficient, that could actually make a noticeable difference environmentally.
Yeah, mitigating that growing energy demand from AI just being used all the time. That's significant.
It is. And it's interesting to see this in the wider market context, too. The article mentions that DeepSeek R1 model.
Ah, yeah, the open weight one.
That's the one. Apparently, its reasoning abilities, possibly at lower costs, and the fact its internal settings are public, that caused quite a stir.
A stir is putting it mildly. Didn't the article mention nearly $1 trillion stock market fluctuation?
Yeah, something crazy like that.
Hmm.
It shows how sensitive the market is to efficiency and cost in AI right now. DeepSeek's open approach is definitely a different path.
But Google DeepMind's CTO, Kare Kavakoglu, he thinks their proprietary approach still has the edge in some areas.
He does. He argues that for stuff needing super high accuracy, things like coding, math, finance, their closed models will still perform better.
Okay, so maybe different models for different needs. Proprietary for high-stakes precision, maybe open models for broader access or different kinds of tasks.
Could be. It suggests the landscape might get more diverse.
This whole reasoning control thing,
Yeah.
it really feels like the AI industry is kind of growing up a bit.
How do you mean?
Well, moving beyond just chasing the highest benchmark scores and starting to bump up against, practical real-world limits, like cost and sustainability.
Yeah, that makes sense.
Yeah.
The article mentions some of these reasoning tasks on leaderboards costing upwards of $200 per task.
$200 for one task.
Yeah.
Well, that's not scalable for most applications, is it? It really highlights why efficiency controls are becoming so necessary.
Absolutely. And Kavukoglu also said something interesting, that reasoning is the key capability that builds up intelligence.
Right. But as soon as that intelligence, that reasoning kicks in,
You run into resource management issues. He said, the moment the model starts thinking, the agency of the model has started. That implies a need for managing that agency, that resource use.
exactly. So this thinking budget isn't just about cost. It's about managing the model's newfound agency in a practical way. It gives developers immediate benefits.
Like making clear trade-offs.
Yeah, balancing how deep the model needs to think versus how much it's going to cost. You can get cost certainty, which is huge, while still aiming for the performance you need.
So for simple customer service questions, you dial the reasoning way down, save money and energy.
Right. But for complex data analysis, you can crank it up and let it use the full budget. It's about having that dial.
That flexibility. And Google's claiming Gemini 2.5 Flash is already cheaper and smaller than competitors while being comparable in performance.
And this control feature just adds another layer to that value proposition. Makes it even more appealing for developers trying to balance performance and budget.
Okay, so wrapping this up then. It really seems like Google introducing this AI reasoning control in Gemini 2.5 Flash, it's a pretty significant move.
Yeah, definitely. A big step towards making AI more efficient, more cost-effective to actually deploy in the real world.
By giving developers that fine-grained control over processing power, they're hitting a really key challenge head-on.
For sure. And like we discussed, it might signal this broader shift in AI development itself, moving beyond just pure scale towards optimization.
And really starting to tackle the practical, financial, and environmental costs of these incredibly powerful systems.
Absolutely. It's about making advanced AI sustainable in multiple ways.
Which leads to a really interesting final thought, building on what Kavikuoglu said about model agency.
Mhm.
Well, he said, the moment the model starts thinking, the agency of the model has started. So as these AI models get better and better at thinking more independently, how do we balance that
Balance the incredible potential they have.
with this increasing need to manage their resources responsibly, their thinking budgets?
Yeah, and what does that mean for how we interact with machines that are becoming, well, more intelligent, more autonomous in their processes?
It's a deep question. How do we manage AI agency and resource use as they get smarter? Definitely something for you, our listeners, to mull over.